Tina slowly. We be working all day long, the push us bunny. We ain't playing no games. Sabatavi, Gani.
Good day, grade 11. Hope that you are good. So this is our last video in solving exponents and sets. So remember, we said on the first video that whenever you are solving or simplifying an exponent or you are simplifying the set, you must remember your laws. Remember, we said that we have two laws for sets: law 1 multiplication and law 2 division. So we said that law 1 says that whenever you are multiplying two sets and you have one root or the same root, you take one root and multiply what you have inside. And then law 2, which is a division, said that when you divide two roots and your roots are the same, you take one root and divide what you have inside. So let's look at this question. This question says simplify. We are given fifth root, root 37 plus root 5 times fifth root again, root 37 minus root 5. So guys, here I can see that the roots here are the same. So to make my life easy, I'm going to apply law 1 of sets. So I'm going to take one root and multiply what I have inside. So this is law 1 that I'm going to use for sets. So I'm going to multiply what I have inside. Remember, since this is a binomial, so I have to open the brackets, or I have to put them in brackets. So times this root 37 minus root 5. I hope that you are streaming now, that you can see that this is a difference of two squares. Now the only thing that is left now, we have to multiply what we have inside, multiply out the difference of two squares. So I'm gonna drop again 5 here, and then we're gonna say root 37 times root 37, which will give us 37, because we know that from laws of exponents, law 1 says that if I have a root 37 times root 37, so the roots here are the same, so I have to take one root and multiply what I have inside. So 37 times 37 is the same as x times x, so we are going to get x squared. So in this case, we are going to have 37 squared. What do we have here? Yes, we have 2, so this will cancel out this. Hence, our answer is what? Is 37. And then you say positive root 37 times negative root 5. You are going to get a negative, because a positive times a negative will give you a negative. But here, root 37 times root 5. The roots are the same, but what we have inside is not the same. So we're going to say here 37 times 5. What do we have? 185. Then positive times a negative, positive times a positive, you get a positive. Root 5 times root 37, we are still going to get the same answer, which is root 185. And then a positive times a negative is negative. Then root 5 times root 5, we are going to get 5. So what will happen here, guys? I know that you are smiling, that you know what will happen. So root negative root 185 plus root 185, they are going to cancel out. Now you are left with what? 37 minus what? 5. So here, guys, we have what? 37 minus 5. So 37 minus 5 give us what? 32. So now it's simple. Now we have to write 32 in what? In prime basis, or we have to find the prime factors of 32. We all know how to find, guys, the prime factors. You just press 32 because we want the prime factors of 32. Then you press your equal sign. Then you press shift here, this button. Then you press fact, this button. Can you see it's 2 to the power what? Power 5. So, which is this the same fifth root here? We have 2 to the power 5. Now, it's easy, guys. You see that, remember, your root definition. So your root definition says that if I have n over a to the power m here, remember, when I was doing grade 9, my teacher told me that before 1994, there was an apartheid, and Nelson Mandela was kept here in Robben Island. So let's consider this your root as your Robben Island, and consider this A as your apartheid. And before 1994, National Party was ruling the country, SA. So now, let's consider this one as your National Party. Is outside Robben Island, is controlling whatever we have inside the Robben Island. But after 1994, Nelson Mandela was the one who's ruling the country. So let's consider this one as Mandela. Let's consider this one as National Party. Then the road as your Robben Island. So after 1994, there was no Robben Island that was used to keep SA or SA comrades. So now we have the apartheid, but Mandela was on top of the National Party. So if we take Mandela out of the prison, it's going to be M over N. Understand? I hope that you understand the root definition. So here, guys, we are going to have 2. Remember, your Mandela now is this 5. So it's 5 over National Party, which is this 5. Now you all see that 5 divided by 5 is 1. So our answer, guys, is 2. So that's the answer for the first question. So let's go and do the next question. So we're given this question. So we are simplifying again. Simplify cube root 3 to the power 6 minus 9 times cube root 27 to the power 3x all over 9 to the power 2x minus 1 times 3 to the power x. So guys, it's simple. Remember your laws. There are many ways to do this question, but I will take the easiest one. So can you see that, guys, in the numerator it's complicated, but I see that the roots are the same. We are going to apply law 1 of sets, which is law of multiplication. So I'm going to take one root here. So I'm going to have a cube root. Then says that if the roots are the same, you take one root and multiply what you have inside. So it's the same as, I will open the brackets, guys, that I have 3 to the power 6x minus 9. Then I open another bracket that I have 27 to 3 to the power 27 to 3x to the power 3x over. Then we have to find the prime basis of 9. We all know that 9, guys, is 3 to the power 2. Then outside I still have our binomials, which is in this case we are still have what? Yes, we are still having 2x minus 1. So times 3 to the power x. So guys, whenever you are solving this, you must remember your laws. So we are going to keep this 3 because we have to find the prime factors of 27 now. So we know that, guys, the prime factors of 27 is 3 to the power 3. So I must open another bracket here and put 3 to the power 3. Then outside we are having 3 to the power 3 times x, which is 3x. Then I close this bracket all over. Now, which law that we can apply here? Yes, it's law number 3 of sets, ne? Or sorry, of exponents. Laws of exponents. So we're going to say 2 times 2x, which is 4x. Right. So 2 times -1, that's -2 times 3x. Remember, we applied here law number 3. So let's come here. So we have what now? Cube root again. So we have these guys. So just let's make it easy. 3 times 3x, what do you have? 9x. So which is the same as 3 to the power 6x minus 9 times 3 to the power 9x. Over which law you can apply on your denominator? Yes, you are smiling at home now because you see that law number 1. The bases are the same. You take one base and add the what? The exponents. So I'm going to have 3. So 4x plus x, what do you get? Is 5x minus what? Minus 2. Now, which law you can apply again here on your under your square root? Or under your cube root? Now you see that you can apply another law 1 again. Then you put your cube root here. The bases here are the what? Are the same. So I'm going to take one base and add the exponents. So 6 plus 9x, we get what? 15x minus what? 9. Alright. Over 3 to the power 5x minus 2. Okay. Now, guys, the aim is to get rid of this cube root. So I have cube root again. But if I open the brackets and apply law number 3, remember, if I say 3 is the multiple of 15, if I say 15 divided by 3, I get what? I get 5. So if I say here is 5 is 3 to the power 5x minus, also 9 is the multiple of 3. So I'm going to say 9 divided by 3, we get another 3. Then we take out 3, guys. Because if we're using law number 1, if I say 3 times 5, we are still getting 15x. If I say 3 times -3, we are still getting -9. Then all over 3 to the power 5x minus 2. Can you see this cube root will cancel this root, this cube? So now, so guys, I'm going to take our step here. So now we have 3 to the power 5x minus 3 over 3 to the power 5x minus 2. Which law now you can apply? Yes, it's law number 2. When the bases are the same, you take one base and subtract the exponent. So now I'm going to take, because -2 is the largest one, so -3 must go down. So I will have 1 on top here, guys. Then we have 5 here, x minus 2. We have having 3 the base here. If we transpose 5 down, the sign is going to change, and you will have what? -5x. But if you transpose -3 down, the sign is going to change and have +3. Okay, so we have the long division here. So 5x minus 5x cancel out. -2 plus 3, we are going to get 1. So your final answer is going to be 1/3. So that's your final answer. Okay, remember, guys, whenever we're doing this question, you can pause the video and try to attempt this question on your own. So let's go to number 3. So number 3, we are given this question. Remember, guys, you can pause the video and try to attempt on your own. So they are saying, show that without using a calculator, that square root of 2 to the power 211 divided by square root of 2 to the power 2013 minus square root of 2 to the power 209 equals to 2/3. This is easy, guys. This is cheap. You can get this one to the spaza shop. There are many ways, again, guys, to do this method. So what I'm going to do, guys, I'm going to consider this part, this side as my left side, this is my right hand side. So there's nothing that I can prove here because this side is simple. So this side is not simple. So I'm going to prove this side to be the same with this one. So I'm going to tell the marker that left hand side here that I'm going to take. But what I need to do here, guys, I have to look at the smallest number because these numbers are big. So I have to look at the smallest number and make it to be the common factor. But it's not the case that you must look at the smallest number. You can take any number which is here, but you must be good with signs. But if you want to avoid negatives, you must take the smallest one to be your common factor. So in this case, I have 211, 2013, and a 209. So which means in 2011, I can find 209 by using the laws of exponents, which is law number 1. So here, guys, I'm going to apply step number 1 here. So I'm going to say 2 to the power 209 because I want 209 to be my common factor. So you're going to say 211 minus 209. What do you get? You get 2 to the power what? 209 is 2010, 211, you get 2 to the power 2. Understand? Because when you multiply the two bases here, the bases here are the same. Take one base and add the exponents. 209 plus 2, you are still going to get 211. So all over base. So 2013, we are still going to have, guys, here 2 to the power 209 times, then guys, we're going to say 2013 minus 209, you get 4. Remember, when they say without using a calculator, they don't mean that you must take your calculator away from you. So you can verify that 2013 minus 209, we get 4, right? So we're going to put 4 here minus the root here of 2 to 209. Yes. Now, maybe when you reach this step, you can be confused. What must I do now? Remember your laws of exponents. Remember your laws of sets. So this is law number 1, laws of sets, which is law of multiplication. So if we say root A times root B, we know that this will give us A times B because we take one root and multiply what we have inside. Because we can see that what we have inside is not the same, but the root is the same. But if it is here, you can take it to this step. Now we can see this one. What we have here is not the same, even if we can let 2 to the power 209 to be x. Now you can see that this one is not the same. So we are going to split this one, guys. We are going to split that we have root 2 to the power 209 times 2 to the power 2. Then we split again here. We have 2 to the power 209 times 2 to the power 4 minus 2 to the power 209. So now this one is the product. We are going to keep it as it is. So we are still here having square root of 2 to the power 209 times. Now we all know that 2 squared will give us what? 4 over, then what is common here? So we can see that, guys, square root of 2 to the power 209 here is common. So I'm going to take square root of 2 to the power 209 as a common factor. So we have this as your common factor. Then you open the brackets. If you take out this one, you are left with square root of 2 to the power 4 will give you 16 minus here we are left with 1. So can you see that this will cancel this? Now we all know that square root of 4 is 2. Square root of 16 is 4 minus this one. So now we have 2 here as your numerator. 4 minus 1 give you 3. Now, which is the same as this one. Now you can conclude that your left hand side is equals to the right hand side. So that's easy, guys, when you know your laws of exponents. So let's do this one. This question, you can pause the video and try to attempt these questions on your own. So we're given this question. They say show without using a calculator again that root 12 plus 2 root 3 plus 3 to the power 1,5 equals to root 147. Okay, right. So we have here root 12 plus root 2 root 3 plus 3,15 equals to root 147. Again, guys, I have an equation here, so I'm going to consider this part as my left side and this part as my right side. So it's simple, guys, when you remember the laws of exponents. I remember, guys, we said on the previous video that under the root you must have the prime number multiplied by the perfect number. That's what you need to have here. So I have root 12 here. So root 12, I showed you that how to get a prime number and a perfect number using your calculator, even though they say without using a calculator. You just press root 12. Can you see is 2 root 3? You have what? 2 root 3, which means the one that goes outside, it was your perfect number. The one that you have inside the root, it was your prime number. So you are going to put this one squared, 2 squared to get what? 4. Then you put 4 inside. So which is 4 times 3 give us what? 12. So that's what we are going to do here. So I'm going to take the left hand side here. For 12, I have root 4 times 3 plus, we are going to keep this one as it is. So which is root 3 plus 3. So we know that, guys, 1,5 is the same as 3 over 2. Okay, so now which law that we can apply here? Law number 1 of Surds. So which means we can split this one to be root 4 times root 3 plus we have to keep this one as it is because we already have irrational number here inside the root. So over 3. So or we have the prime number because irrational number is root 3 only plus. Remember, guys, let's take Mandela inside the Robben Island now. So we are going to have Robben Island. Then we have our apartheid. Nelson Mandela was ruling because now we are here after 1994. Mandela must come inside. Then the National Party must come here. Okay? So what do we have here, guys? Square root of 4 would give us 2 root 3 plus 2 root 3. So here, guys, we have this. We have 3 to the power 2. So we know that it's plus here. Doesn't matter to write 2 because we know that if we have nothing here, it always 2. So 3 cube would give us 27. All right. Okay. Hope that we are good. So now you are adding the what? The sets. It's more like you have 2x plus 2x. So 2x plus 2x give you what? 4x. So here, 2 root 3 plus 2 root 3 will give us 4 root 3 plus, remember, we are having 27 here. We need to find the prime number and the perfect number. you just press root 27. Can you see that 3 is outside? So you just say 3 squared, you get 9, then you push 9 inside. So it's the same as we have 9 times 3. So this is 4 root 3 plus root 9 times root 3. Guys, we apply law 1 of sets. So now this is 4 root 3 plus root 9 give us 3 root 3. So can you see, guys, we have 4 root 3, which is the same as 4x. Then we have 3 root 3, which is the same as 3x. So if you add the 2, you are going to get 7x. So if we add the sets here, we are going to get 7 root 3. Now, you're asking yourself again, is this what I want? No, because they said you must get root 147. But if you can press root 147 on your calculator, you are going to get this one. So if we can put the squared outside here, because we know that if we get this answer, it tells me that 7 was the perfect number here. Then we put the squared here and put 7 squared inside. So 7 squared give us what? 49. Give us 49. 49 times what? 3. If you press 49 times 3 on your calculator, you will get 147, which is the same as this one. Now you can conclude that your left hand side is equal to the what? To the right hand side. So this is our second last question. So guys, so you can pause the video again and try to attempt these questions on your own. So they are saying if x is equals to square root 3 minus 2 root 3 and y equals to root 2 minus 1, prove that y equals to x without using a calculator. Wow, this is interesting. So we have to prove that y is equal to x. This is what we are required to prove. This is good. So you just have to breathe in, breathe out, and enjoy mathematics. So we all know that, guys, if I want to prove that y is equal to x, which means that if I take this value and substitute here in place of y, I must get this value of x. Same applies if I take this value of x and substitute here in this place of x, I must get this value of y. That's what the examiner wants here. You don't have to equate the two equations. Just take this number and take this number. You are going to confuse yourself. So what he wants here, or she wants, the examiner wants that you must take your y and substitute here. You must get this one. Or you take this one and substitute here. You must get this y. So I'm going to take this x, guys, and try to prove it to be this one. So I have y here, then your x was 3 minus 2 root 2. Okay? So now I'm asking myself, what must I do in order for me to get this? And maybe you are asking yourselves too. So guys, I'm going to drop y again. Let's try to split 3. We know that, guys, 3 is the same as 2 plus 1. Okay? So we have this minus 2 root 2. Okay. Since, guys, 1 is a perfect number, I'm going to push it to be the last number and put 2 here to be the first number, minus 2 root 2 plus 1. Why I do this? Because I see that I have root 2 here. Remember, guys, because this is what I want to get here. So if I say I open the brackets I put the squared, I take this as it is, or you factorize this to be root 2 minus 1. You are still going to get this one, because if you take it out to be like this, because this, when we put 2 here, we mean that this, it duplicates. So which means I factorize this. So root 2 times root 2, you get 2. Root 2 times negative 1 is negative root 2. Negative 1 times root 2 is negative root 2 again. Negative 1 times negative 1 is positive 1. 2 plus 1, you get 3. Negative root 2 minus root 2, you get negative 2 root 2, which is the same as this one. Okay? So now we already know that we always have 2 here. If it is not written, it is not cube, or this cancel out. So now can you see that your y is equal to root 2 minus 1? Oh, then I'm happy. Yes. So now you're asking yourself, so what will happen, say, if I took this y and try to prove it to make it to be to look like this x? Okay, let's see what will happen, because this must give you this, and also this one must give you this, as you see here. So I will equate again. Remember, if I want to take this one to look like this, I have to square both sides so that I can kill that larger, the big square root. So I will say squared here, squared here. So, okay guys, we took this one. We already used x, now we have to use y. Okay, so if I took this y, I have to square, because I cannot get this. So if I say we have inside root 2 minus 1 squared equals to x squared. Alright, guys, I already expanded this for you. I know that you see the working here. We are going to copy this one as it is here. So I have root 2 minus 1, root 2 minus 1 equals to x squared. So root 2 times root 2, you get 2. Root 2 times negative 1, you get negative root 2. Negative 1 times root 2, you get negative root 2 again. Negative 1 times negative 1, you get positive 1 equals to x squared. So 2 plus 1, you get what? 3. Negative root 2 minus root 2, you get negative 2 root 2 equals to what? X squared. So now you ask yourself, we were looking for x squared? No, we were looking for what? For x. Then I introduce the square root here. So this cancel out. Now we can conclude that our x is equal to root 3 minus 2 root 2 here. So this is your answer. So this is when you use your y to show that is equal to your x. Then here we use x to show that is equal to this y. So that was easy, guys, but it was tricky. So let's do the last question that we have here. So we are given here, if m and n are rational numbers such that root m plus root n equals to root 5 plus root 24, calculate the possible value of m squared plus n squared. Ooh. So guys, you can pause the video and try to attempt this question on your own. So now it's easy, guys, for me, because I see that my starting point here is here. Okay, right. So let's copy this question down. And we all know that, guys, the rational numbers are numbers that can be written as a fraction. So if I get maybe square root of 2 as my m, or m squared plus n, so I must get here the rational number again, because we know that m and n are rational numbers. So whatever that we do here, we must get again a rational number. So I have square root of m plus square root of n equals to square root of 5 plus root 24. Okay. So the first step, you're asking yourself, What must you do here in order for you to get m squared plus n squared? But the first thing that I must do here, I must get n and m before I go to m squared. So what must we do if we want to get m and n, guys? Yes, we have to square both sides. So if we square both sides, because the maths law says that whatever you do on your left side, you must also do it on your right side. So this, guys, it duplicates 2 times. We have root m plus root n, root m plus root n. Okay, hope you are with me, grade 11. So here we have 2, so this will cancel this. Now we have 5 plus root 24. Okay, so now root m times root m, what do we get? It's m. Root m times root n, you get root m n, because the laws of exponents says that whenever you are multiplying the 2 roots and the roots are the same, you take one root and multiply what you have inside. So then plus root n times root m, you're gonna get m n, root m n. So positive times a positive, it's a positive. Root n times root n, it's n again. So it's 5 plus root 24. Okay, so now we drop m. So root mn plus root mn, you get, guys, 2 root mn plus n. Okay, now we have to apply the laws here. If you press your calculator, root 24, can you see it's 2 root 6, which tells me that if I put 2 squared, because always you just put squared here with this number outside because it was a perfect number. So 2 squared give us 4, then we push 4 inside so that we hide the steps of calculator. This is 4 times 6. So you drop this one again, m plus 2 root mn plus n. So this is 5 plus, then you split this one using law number 1, laws of sets, which is root here, root 4 times root 6. So then we drop again m, then we have 2 root mn plus n. So this is 5 plus root 4 give you what? 2 root 6. Wow, then I'm happy. Guys, push this n forward. If we push this n forward, this is n, m plus n. Then let's close the brackets here and make it one term. Plus 2 root mn equals to 5 plus 2 root 6. Okay, now, guys, can you see that this one is the same with these 2, which means I can equate. So this one will be equal to this one. Alright, so now I will say here, guys, m plus n must be equals to 5. So if I say and 2 root mn must be equals to 2 root 6. In other words, guys, mn is equal to 6. Now just divide by what? By 2 here. You will see. So this cancel out. Then you have root mn is equals to, this cancel out, root 6. What you must do in order for you to get mn? Yes, you square both sides. So this cancel out. Therefore, your mn is equals to 6. Let's go to this one. Now, guys, here we have m plus n. Remember our question, they want m squared plus n. Then you ask yourself again, what must you do in order for you to get the squared? M squared, yes, you must square both sides. Okay, so now you have m plus n all squared, so which is the same as m plus n. M plus n, 5 squared give us 25. So m times m, that's m squared. M times n, that's mn. Then we're done with this m. Then n times m, that's mn. Then positive n times positive n, that's n squared, equals to 25. Right, so this is m squared plus then m plus mn. Sorry, mn plus mn, you get 2 mn plus n squared equals to 25. Ne? But mn, guys, is equal to what? To 6. So here in place of mn we put our 6. So we have mn here plus 2 into 6 plus n squared equals to 25. So this is m squared. So 2 times 6 you get what? 12 plus n squared equals to 25. Don't forget what you want, guys. You want m squared plus n squared. What you must do now, you must transpose 12 to the other side. So you're going to have m squared plus n squared equals to 25 minus 12. So now therefore m squared plus n squared is equals to 25 minus 25 minus 12, you get 13 as your final answer. Okay, that was easy question, but it was tricky, guys. So I hope that you understand the steps here. So the principle of maths, you just repeat what you did again and again. You will see, you will develop your own techniques. So guys, thank you for watching. If you didn't subscribe, please don't forget to subscribe. Like the video, tell us how do you feel about our lessons. Thank you, see you next time.